Alright guys and gals, welcome to video lesson 2-4, our lesson on deductive reasoning. Here we go, here we go, here we go. Deductive structure. Deductive reasoning is logic based upon proof. Proven statements. Nothing is true until we can prove that it is true. When we are using deductive reasoning in geometry, we're doing that in proofs. Okay? And whenever we do proofs, there are going to be a number of different things that we can use to justify our statements. They might be undefined terms, which are just basically definitions. There are undefined assumptions known as postulates. There are definitions, which we'll talk about, and there's theorems, which are proven facts. We'll talk about those things as well. But that's just the idea behind deductive reasoning. Deductive reasoning is based upon proof. And if you remember now from before, inductive reasoning is based upon observation or conjecture. Of these two statements, 1 and 2, which one of them is inductive, which one of them is deductive? In other words, if I say Jan noticed that boys don't wear dresses, is that inductive or is it deductive? Very good. That's inductive. Jan is just kind of guessing that boys don't wear dresses by what she's seeing, by her observation. There is no rule or there is no law, and certainly it's possible that we might find some boys who are wearing dresses. However, in the second one, if you are driving 75 miles per hour, then you are speeding. That is deductive logic, because there are actually laws that say, written down, that say if you're driving over a certain speed limit, then you are speeding. If you look at the second two statements, angle 1 and 2 are supplementary. That's going to be deductive, because we know that these two angles right here do add up to 180 because they are linear pairs. We know that. That's been proven fact. And number 2, angle 2 appears to be obtuse. Yes, it does appear to be, but that's going to be inductive, because we're just basing that upon what we're seeing and our observations. Okay, and maybe your eyes don't work right. Okay, here's what we're going to be doing today. We're going to be talking about chain of reasonings called law of syllogism. In other words, if P then Q, if that is true, and if Q then R is also true, notice that P goes to Q, Q goes to R, which means now these are the same. So if P is true, then we can go directly to R. We're going to talk about these steps in a couple minutes, but you already have them written down, so we will come back to that in a momentito. So looking at this little problem right here, we see if Dave dunks the ball, then Lizzie licks the lollipop. If Tom trips, then Dave dunks the ball. If Steve swims a mile, then Tom trips. If Lizzie licks a lollipop, then Jace juggles 3 balls. In other words, we're going to see, is there a chain that we can come up with this to come up with a single statement. I'm just going to write
Jeffers, please phone the main office. Mr. Jeffers.
I'm just going to write all of these down real quick and just with letters to make things easier. So I know here I got D, then L. Here I got T, then D. Here I got S, then T. And here I got L, then J. So what I'm going to do now is I'm going to look, and is there any letter or letters that are only appear once? And it looks like that S only appears once, and J only appears once. So I'm actually going to start right here with the S. So I'm going to write here, S goes to T, and then here I know that T goes to D, and then here I know that D goes to L, and then lastly here I know that L goes to J. So basically Steve goes to Tom, goes to Dave, goes to Lizzie, goes to Jace. So basically, if Steve then Jace. So in other words, if Steve swims a mile, then Jace will juggle 3 balls. Now, as we can follow this chain right through, if Steve swims, then Tom trips, which means Dave dunks, which means now, so I'm going to start here. If Steve swims, then Tom trips, which means now Dave dunks, which means Lizzie licks, and then Jace juggles. Okay? You guys try this one. Go ahead and see if there's only 3 statements here. See if you can come up with a syllogism. Okay, first you should have written down 8. We should have written down P then M, H then P, C and S then A, and M then C and S. We notice now we only have one H and we only have one A. So we're actually going to start with the H. Okay, we're going to start with the H right here. So if human, then you are a primate. If you are a primate, then you are a mammal. If you are a mammal, then you have a central nervous system. And lastly, if you have a central nervous system, then you are an animal. We can abbreviate that, and we can go directly say, if you are human, then you are an animal. Okay, let's try something a little bit more difficult. This only has 3 statements, but now we also see some negations in there. In other words, we see some nots. So I'm going to start by just writing the first one. Okay, and looking back, and again, looking back at those steps, my first step is to write these things in terms of symbols. So I'm going to say, if a cat is a lion, then it lives in a pride. So if lion, then it lives in a pride. If it's not a house cat, then it lives outside. So not a house cat, then it lives outside. And if it's a house cat, then it does not live in a pride. Okay, so we have 3 statements right now. If L, then P. If not H, then O. If H, then not P. I'm also going to write down the contrapositive to each of these statements. The contrapositive of if L, then P is if not P, then not L. Remember, the contrapositive both reverses and it negates. Okay, so we reverse and we negate. So this is going to be not O, then not H. Well, not H is H. The negation of a not H is yes H. And the last one is not P becomes P, then not H. Now this is a little bit harder. Looking at both the blue and the brown here, are there statements or are there letters that only appear once on each once in only one line each is what you're really looking for, in one line each. And it looks like, yes, there is only one O, and there is only one L. So we need to start with either the L or the O, and it doesn't matter, to be honest with you. But I'm going to start right here. I'm going to start with the lion. Okay, so I'm going to start with the lion right now. So L. Sorry, I gotta get my pen back up here. Go green. So I'm going to start with the lion, and I'm going to go to the P. So I'm going to start right here with 1. So if L, then P. I'm going to go down here to 2, but over on this side, I'm going to say, oh, if P, then not H. And then lastly, I'm going to say, oh, I'm going to go 3 right here, but go back to this side. If not H, then O. So I basically know if a cat is a lion, we'll go back down here so we can see it, then it lives outside. Okay? Then it lives outside. Notice we could have also started, in lieu of starting with the L, we could have started with the O. So if we had started right here, I'll do this in red. I started with not O, then H, so not O, then H. H then goes right here. H, then not P. And lastly, I'm going to go not P to not L. I can summarize that by saying if not O, then not L. So if if a cat doesn't live outside, then it's not a lion. And notice that this statement right here in black is the contrapositive of our first statement, which was if L, then O. These two things are contrapositives. And if we know that if one is true, then the other is also true. You guys try this one. It's already written in code form. We need to write the contrapositives and then come up with a chain. Okay, if you look at this last one right here, I'm actually going to start with if B, then not O. That takes me to not O, then K. That then takes me to K to not M, and not M to C, which I made that chain right down here, which you can see. Okay? And then my final statement then is if B, then C. Alrighty, folks, I think the homework is a little bit long, so give it a go, and we'll see you soon. Bye-bye.